Yes,
You're
sir.
audible, sir. Siraj,
Yes, sir.
sir, you're audible. Yeah.
Thank you. Thank you very much for your response. Uh, Good evening, one and all. This is Dr. Mohammad Sirajuddin, co-coordinator of this online Atal FTP. I welcomes you all to the fifth day of 6 days online faculty development program. Uh, it is my privilege to invite today's eminent speaker, Mr. Kiran Kumar sir. Mr. Kiran Kumar sir is a esteemed IT professional with 20 years of industry experience in leading large-scale enterprise projects, cross-functional teams, and delivering innovative technology solutions. Currently, serving as a technical lead at TCS, Atlanta, USA. He specializes in architecturing, implementing end-to-end solutions for global clients, ensuring high performance, scalability, and security. He has previously worked with IBM and Capgemini, where he gained extensive expertise in software development, cloud transformation, enterprise applications, and IT consulting. His career reflects a strong track record of driving technology adoption, managing client relationships, and mentoring teams across domains and geographies. So, thank you very much, sir. Thank you for joining us. Over to you, Kiran, sir.
Thank you, Siraj, sir. That was like warm welcoming. So I won't take much time for my introduction. I'll just give a quick intro. So hello, good evening, everyone. A warm welcome to the session. So as I said, little introduction about myself. I'm Kiran Gazlek. Currently, I'm in USA. I'm working for an MNC as a software technical architect. So that's I have around 20 years of experience in this area. So that's short intro about me. And it's my pleasure to be part of this session. So I think it's day 5, session 9. Yeah. And would like to thank Vageshwari College for this opportunity and also experts who participated in these sessions. So I couldn't join all sessions because of time constraints, but attended a couple of them. So in last few days, uh, really like the expertise on the subject on quantum. So I attended Kishore sir's class, Ranjit sir. So the information they provided was very informative, and they have very good knowledge on the subject. So without delay, I will get started. So in this session, we will be discussing about quantum. Let me share my screen. Sorry. Let me know if you can see my screen. Siraj sir, could you please just confirm?
Yes, sir. Your screen is visible, sir. Voice is also
All
very
right.
clear. Please
All
carry on,
right.
sir.
Perfect. Perfect. Yeah. So, yeah, we'll be discussing about quantum ready cybersecurity. So we'll just explore the risk management and complaints side of it. And I hope you had a discussion of the information about basics on the quantum technology in the previous sessions. So it's one of the most important transition happening in the cybersecurity area. So the arrival of quantum computing and what it means for the way we protect information, like how we're going to protect the information. That's a major transition happening. So far, like quantum technology is it was theory, like so far we are learning about that, but that was not in production yet. But it's no longer more like it's moving into reality soon. So while it promises breakthroughs, it also creates major risks for how we secure and protect the information. So in this session, we'll explore what are those risks looks like and the challenges or how organizations can manage them and the compliance steps that will become necessary in the quantum area. All right. With that, I'll move on to today's agenda. Here is a quick agenda what we will cover today. So first, we'll be talking about quantum security landscape, like what is changing and why it matters, like understanding the risks and challenges. And next, we'll walk through the risk management cycle, like identification, assessing, mitigation, and monitoring risks in the context in the quantum area. Then we'll connect this with compliance requirements, since regulators or the bodies are already starting to pay attention to these issues. Yeah. And after that, we will talk about the auditing and risk mitigation, and ways to reduce uh, quantum risks. And finally, we'll just go with the crypto agile framework, like making sure our systems are flexible to adopt this technology in near future. And so this is first session, like a half session agenda, and then next half we'll discuss about the blockchain and AI, how it is going to integrate with the quantum. All right. Moving on to next slide. The quantum security imperative. So why this is important? Why quantum is important? So quantum security important. So traditional cryptography is like they faces an existential threat from quantum computing services, so potential to break the encryption method that protect almost everything we do online today. So what we do in online today, like from banking and healthcare to government, all corporate systems, right? So everything we are doing online. So especially if you're aware of this RSA and ECC, they are the encryption keys which currently being used in all the infrastructures, or all the applications. So there is a chance that Shor's algorithm can break those RSAs and ECCs. So this is more than technical. It's about keeping information safe for long term. What makes this urgent is that so attackers no need to wait for a working quantum computer. So they can just they can just get the encrypted data now, and they can just unlock it later when the quantum computers are ready. So this is often called so what we call there is harvest now and decrypt later attacks. So what attackers will do is they will collect the data now, and they will use that afterwards to decrypt it. So that is why it, so so security teams must identify vulnerable systems. So they must spot what is vulnerable, and they should come up with a plan for protecting those assets. So that's a threat is and it is real today. Like even if large scale quantum computers are still being developed, they're still being developed stage. So the risk they bring are already shaping like how we could think about the security and all. Right. So one key principle is risk management is not just about compliance, it's about business continuity in the quantum era. So we need to assess the risks in an organization so in such a way that it should not impact your business continuities. Like if you are impacted, or if you are attacked by a hacker, or if your data has been decrypted, it should not impact your business. Your business should run as usual. So that is the key principle. So we'll just go over the cybersecurity risk management in the quantum era. So, so how do we actually approach this problem? So how to assess the risks and all. So I'll just spend some time on this. So this is the major one here. So how we are gonna identify, assess, and mitigate, monitor these risks in the in this area. So we use the same risk management steps we already know in our legacy or usual current security methods, but we'll try to apply them to quantum, like see how it is. So step one is identify. So identify is something like we need to figure out where encryption is being used in your organization, like what applications are being used, what technologies are being used, to figure out like exactly where quantum risk exists in the system. So as we discussed previously, like things like RSA, ECC, those are the encryption keys, or and also other digital certificates. So in simple terms, so identifying is about looking into every corner of uh, an organization IT environment, and asking like what could impact more with this. So that is identify phase. Line moving on to assessing. So once we know where are the risks in our environment, so next step is the risk assessment. So now we identified, we need to assess those risks. So this is about answering two big questions. First one, it would be like how likely is it that the system will be exposed to quantum threat, like how it is gonna impact. So we identified, we assess this is gonna impact, but how it is gonna happen, so that is one thing. And how bad would the impact be? So like if someone attacked your systems, like how bad it would be, like how it's gonna be impact your systems, your overall organizations. That's the second one. So I'll just take small example here in assessing, like if a system contains like old customer records that no one uses currently, so the risk might be lower there because no one is using. No, so if someone decrypts that also, so it's not going to cause any harm. But if it contains financial transactions or government data, that must say stay secret, right, for decades. Like so we'll be having, we need to keep that data for our history or for longer term. So in that scenario the risk is extremely high, so we need to identify and then assess like what are those things we need to look for there. So once we assess, then we need to mitigate that. So basically in so assessment, I just want to add one more there, like it's about prioritizing, like what you want to take up first, what which areas you want to address first from the identified assessments, yeah, identified list. So then step three is mitigate. So after we identified and assess the risk, we move to risk mitigation. So this is where we start thinking about the solutions. So one major approach is testing the post quantum cryptography, that is called PQC, yeah, post quantum cryptography algorithm. So it is designed to resist quantum attacks. And another key strategy is building a crypto agility frameworks. So which means designing systems that can easily switch to new encryption methods as its standards, yeah, its standards evolving. So the message here is like we don't wait until the threat is at your until threat reaches us, start experimenting now, and so the transition can be smoother once we identify that. So it should not be a problem at all. And step four is monitoring. So this is going to be your last step in risk monitoring. Content technology is evolving fast now, like it's happening now. So far it was like theoretical, but it's happening now. For example, NIST is like our US National Institute of Standards and Technology. NIST is in the final stages of choosing the post quantum algorithms. So that's leading actually. So regulations or regulator bodies may catch up that one soon. So monitoring means we need to be active and alert. So we need to keeping track of new guidance or watching for changes in the threat landscape, and need to update the plans as needed. So that's where monitoring stands. So this cycle gives us a overall structured way to prepare, so for the future, instead of just waiting and reacting when it comes up. So this mechanism is just preparing for the future. All right, moving on to next, quantum risk assessment matrix. So I'll divided the risk this risk into multiple categories, like three categories: high risk, medium risks, and low risks. So we'll just discuss about what are those and all. So high risk areas includes things like PKI, authentication and certificates, and long-term encrypted data related ones. We need to we remain secure for 10 plus years or more. And industries like finance, defense system, or healthcare, where we stay are very high. Even VPNs and secure communication channels also fall in this group, because like if they're broken, VPN is broken, the entire organization can go down. Like VPN is the first step to access the any organization network, right? So that's why it falls under the high risk assessments. So first, yeah, these are the high risk, and medium risk, or like business critical systems or business partner integration systems, customer facing encrypted implementation, and internal communications system with planned replacement cycle. So these are all falls under the medium risks. So these are also important, but slightly less than the high risk group. Risk is impacted, then we are gonna have organizational wide impact, but mediums can still sustainable. So like if someone attacks these assets, still we can continue our yeah, organization. And the low risks are like uh, systems with short-lived data, legacy systems that are about to retire, or non-critical internal tools. So these don't need the same level of immediate attention like the high-end medium risk assets, but yeah, still we need to fix those on the lower also. But the priority would be high risk and the medium risk assets. So yeah, just separating systems into high, medium, and low, so we can just focus our time and so what matters. Yeah. But, moving on to the next slide, involving compliance landscape. So now, like, so far we discussed about the risk, right? Now let's we'll move on to this complaints landscape, like how it is. So as I said, like regulatory bodies and industry are already working on the framework for quantum readiness. So even if the details are still being, it's still being finalized, it's not finalized yet. So organizations need to start paying attention to these efforts. So example like NIST. NIST, as I said, like it's leading the standardization for post quantum cryptography. So that is leading there. And NSA has updated its commercial national security algorithm suit, just 2.0, it came up with 2.0. And in Europe, uh, EU Cybersecurity Act also pushing quantum readiness certifications. And OMB, that's Office of Management and Budget in US. Yeah, Office of Management and Budget has also issued telling federal agencies to prepare for that one, and financial regulators. So, like, yeah, as it mentioned, Basel Committee and Fed guidance, they're also beginning to publish guidance. So, basically, I want to say, like, all the regulator bodies are preparing for this one. So, compliance requirements are coming, and organizations also that start aligning now. We'll have a big thing coming up for this one. Yeah. Regulatory requirements by sector. So this slide talks about the different sectors, different regulatory pressures. So the HIPAA, high tech. So those are all the regulation bodies. So we'll just go one by one. So in healthcare, regulations, the regulation bodies like HIPAA, high tech. So they need the confidentiality of patient data. So because like if health records need to stay secure, right, for decades, if quantum computer pose that as a serious threat. So those regulation bodies are coming up. In finance, PCI DSS, like payment card gateway. So SOX compliance means that transaction and customer data must remain secure. So regulators are already, yeah, coming up that quantum readiness will be expected in the near future for this one. And also in for government and critical infrastructure frameworks like the mentioned like FISMA, FedRAMP, and CMMC are beginning to mention post quantum cryptography. And the global business like the laws like GDPR, and NIS 2. GDPR is like the General Data Protection Regulation. So and also NIS 2. So they emphasize like security by design and by default. So this principle will extend the quantum security as well. So across all these domains, healthcare, finance, government, infrastructure, and global regulations, the trend is the same. Like quantum readiness will be a requirement. So it is gonna be a requirement. It's not gonna be choice anymore because trend is moving in that way. Right. Next slide on key compliance insight. The key insight on this slide is that about absence of explicit quantum security mandates does not eliminate liability for breaches. So regulators expect companies to take reasonable security approach. That means acting in anticipation of knowing risks, even if the official standards are still being finalized. So just we need to know what are the risks. As we are still waiting for the standards to be finalized. Okay. Role of regulatory bodies in quantum safe transitions. So so once it is ready, like finance, so regulator will play a central role in this transition to quantum safe systems. Like their responsibilities include setting technical standards for post-quantum cryptography and also establishing compliance guidelines for critical industries and also uh, issuing clear best practice recommendations, implementation guidance. They also need to create a framework that helps organizations of all size make the transition. So creating certification frameworks they're working, yeah, and also most importantly, regulators will enforce the standards, ensuring that organizations actually adopt quantum safe practices. So, in short, what one liner from this is like regulators won't just guide the transition, so they will require it. Cybersecurity audits for quantum vulnerability. So, when we talk about preparing for quantum risks, so one of the most practical tool we have is cybersecurity audit. So this type of audit begins with the scope definition, like identifying all systems in our organization that use cryptography. That includes like authentication systems, data encryption, key exchanges, and certificates. Once the scope identified and it is defined, it is clear, then we'll move on to discovery and inventory. So this is where we document the cryptographic algorithms in use, the key sizes, implementation details, and the data protection requirements, and that kinds of data they are protecting. Yeah. So the next step is vulnerability assessment. So we evaluate each system exposure to quantum threats. We look how sensitive the data is and how long it needs to stay secure. So that is the vulnerability assessment, like how long we need to keep that and how sensitivity the data is. Finally, the cybersecurity audit ends with reporting and remediation. So prioritize. The goal is to prioritize the findings and build a clear migration roadmap. So complete the risk metrics that a leadership can understand. In other words, like audit takes the big unknown of quantum vulnerability and turns it into a actionable plan. Yeah. So this slide talks about the risk assessment of cryptographic assets. Like cryptographic assets are like the encryption methods we have currently in place. So we'll discuss about like each, like how it will be impacted and all. So once we edited our system, right, in previously, the next step is to assess the kind of individual cryptographic assets. Like these are the encryption assets. So for RSA, whether it is 1024 or 2048, sorry, 2048, the risk is severe. Like a Shaw's algorithm, right? So it makes it vulnerable to, it can detect and so bypass the data decryption. That means mitigation has to be immediate. It is critical and it should be done immediate for RSA encryption ones. And same with the ECC also. That's elliptic curve cryptography, like P2P6, P384. So it also faces the same severe risk, like quantum computing can compromise keys and it folds signatures. So again, this falls under the top priority one. And Diffie Hellman key exchange is also broken, but so it's not critical as the other two. So it can be classified in the high mitigation priority. And AES 256 is stronger, but yeah, that falls under medium. And the last one is like SHA 256, that is low one, like because it's less exposed, but still we can. So its collision resistance is affected, which makes it low priority one. But still, again, we need to act on that one, but it can be in the lower priority one. So this is clear, like almost every algorithm or every cryptographic asset we relate today has some level of quantum vulnerability. So, and we need to prioritize mitigation accordingly. Okay. Steps to mitigate quantum security risks. So, we talked about like mitigation, right? But how do we actually mitigate quantum risks? What are the methods we have currently, or the futuristic methods? So the first and the most important one is like migrate to post quantum cryptography. So as I said, like NIST is working finalizing new algorithms on this one. Organizations should begin adopting them. So the safest approach is to start with hybrid implementations where classical and post quantum algorithm works together and focus first on the most vulnerable systems. So that should be the first one. And the for deploy quantum key distribution. So for ultra sensitive communications, quantum key distribution can provide an extra layer there of protection. So this can complement the traditional encryption methods and is even offered as a service in some markets. It's yeah, in some markets it's not in live yet. Finally, we need to adopt the security by design principle. So that means enforcing crypto agility, embracing zero trust architectures, and decoupling cryptography from applications. So changes can be made quickly and safely in the future. So we need to follow. But crypto agility, the foundation of quantum readiness. So one second. So far we talked about the mitigating the quantum security risk, right? So this is another way, like building the crypto agile frameworks. Like this is a foundation. So crypto agility is the foundation of being ready for the quantum area, like quantum era. So what it means is simple. Like we design our system so that we can rapidly transition from one cryptographic algorithm to another. So like we discussed about those RSA, ECC, all right. Those are the assets. So we can move from one to another without having to redesign the entire system or disrupt the business. So we can do without disturbing the business. So if you are not agile, so every update becomes a like big project. Like we need to be ready, so that we can just make changes without disturbing the business. If you're not ready, then it becomes in a big project. Like we need to take systems downtime and all, and we need to proceed with that. But with agility in place, like change becomes routine and manageable. So that's why crypto is at the heart of quantum readiness. So implementing now we'll just a crypto agile architecture, implementing a crypto agile architecture. Now we so how do we actually build these frameworks? So first we use abstraction layer that separates crypto implementation from the application that depends on them. So this is the abstraction layer. So where will application that depend on them. That means like applications don't break when algorithms are updated. Like even if the algorithms are updated, the applications won't break. So then the second is we centralize like cryptographic service management. So policies, updates, and monitoring can all be controlled in one place. And we enable the algorithm configurations. That way we can change an algorithm just by updating parameters, or not by rewriting the code and all. Yeah, we uh, we design for runtime negotiation. This allows the system to agree on which algorithm to use at any given time and all. And finally, we maintain comprehensive inventory and map of all cryptographic dependencies, so nothing slips through the process. Right. Continuous monitoring for quantum readiness. Quantum readiness is not one-time project. It has to be it has to be continuous, as you see in the headline, right? It has to be continuous. It has to be maintained continuously. So that starts with monitoring threat intelligence. Like if you need to track advances in quantum computing, or and indicator of what is sometimes called Q day, like the point when quantum attacks becomes practical, right? So that we need to continuously monitor, like when it's gonna start, we never know, right? So that is a continuous one which we need to monitor. And we also need to monitor our cryptographic posture, like by using automated scanning tools to identify vulnerable implementations across the environment. And at the same time, like migration um, progress towards migration should be it should be tracked carefully, like track PQ's implementation metric against your quantum readiness roadmap. So it is just like, are we meeting roadmap milestones, or are we on pace with the compliance deadlines? So that's the migration progress we need to track there. And finally, like penetration testing. So this needs to be evolved to, like we have to conduct specialized assessments that focus on quantum related security assessments, quantitative vulnerabilities to make our defenses or actually effective. So these are continuous ones. So continuous monitoring. So if we want to be quantum readiness, then we need to monitor all these things, like Q days to identify the threat intelligence, and also continuous scanning tools to identify the any vulnerabilities, yeah, mitigation progress, and the continuous testing also. So this slide talks about the sample timeline for security program, like uh, what security program might look like in phases, like what phases we need to follow and all. So in phase one, so it's an assessment. It's about 3 to 6 months we need to assess. So we complete a full inventory of cryptographic assets, like perform risk assessments and develop quantum readiness strategy. Crucially, this is also when we secure executive sponsorship to fund and support the program. So like we need to get approvals from our executive management, right, to whether what need to be started. And also this is the initial assessment that falls under. In phase two, we it's a foundation one. So usually it takes 6 to 12 months. So this is where we begin building the foundation. Like that means implementing crypto agile architecture, starting hybrid implementations, addressing the high risk items, and putting governance framework in place. So yeah, this process, this foundation, it will take 6 to 12 months, and once foundation is done, we'll move on to migration and phase three. So it usually it will take some time. So migration is something like you need to touch all your environment and you need to migrate this, right? So it won't happen on fly. So it needs some time. So we move into migration. This is where we deploy that approved the like NIST approved standardized algorithms. Like so currently NIST is leading on that, right? So once that is done, so we can just uh, deploy that NIST standardized programs algorithms as they become available. So migrate all quantum mutable systems and also update the third-party dependencies and validate complaints once it is done, migration is done. And in finally in phase four, it's going to be optimization. So this is optimization is something like which is ongoing. So we do not have so because migration, if migration is done, then we are done. Like we are in quantum security. So but yeah, so once migration is done, so optimization is like ongoing thing. So we need to optimize. It should be continuous monitored. So we need to perform tuning of algorithms, like integration of new threat intelligences, and also regular penetration testings, which we discussed earlier. So all these we need to ensure that it doesn't stop once you are done with the migration. Like migration, we are done, but we need to ensure that. Uh, Continuous monitoring is in place for this one to optimize. Yeah, building your quantum risk management team. So usually for any organizations, yeah, we need people, right? So no program or any program can succeed without the right people. So leadership comes first. CISO, like a chief information security officer. So is the like board director, security director, so and also security directors and risk managers set the strategy. Like they will allocate the budget for this migrations, like and keep executives informed, like what we are going to do, what is our strategy on this one and all. So then we'll need the technical specialists like cryptographers, architects, and yeah, DevSecOps engineers. So they understands the algorithms and they are responsible for algorithm selections, what is the best for our environment, and they will design the implementation plan and also integration plan with the new solutions. They will explore more options like what is the best algorithm search for our environment, and they will deploy that one. Compliance and governance. So these roles are also very critical because this is new technology which is coming up. We don't know the legal terms of this one or the compliance yet. So legal teams and compliance officers and auditors, so they track the regulations. They look after the all the regulation. They will read the regulation policies, or what is changing, what is keeping, so how trend is moving and all. So they will maintain the documentation, and they will ensure that we meet the respective standards. So we are not deviating from anything. These standards has been set up. So that's the role of complaints and governance. And finally, business stakeholders, they are the product owners, like in an organization, IT leaders or application teams. They they play a critical role in assessing business impact and coordinating implementation. So because they are the ones who knows how their application is, how it is impacted, if it is exposed to this decryption, the threats. So they should assess and they should make sure that their business is running as usual, even if it is impacted one or two systems, or if, even if that impacts their systems there. So they are the key stakeholders who can decide, and they should come up with like the we discussed, right, the levels: low risk, high risk, mid risk, so assets. So they are the ones who are gonna assess and share that with the technical specialist there. So which one we need to start first, and then move on to the low priority ones at all. Okay. Key takeaways so far. So first, the quantum threat is not just theoretical. So, so we discussed that harvest now, decrypt later attacks, like get the data now, and once quantum is available, they can just try to decrypt that. So that danger is already here. So that means like we need to begin with inventory assessment and strategy development starting from today. All the organizations, they need to focus on that one. And second, prioritize wisely. So focus on systems that protect long-term data, like PKI infrastructure and signature verification first. And because these are the most vulnerable systems and most critical ones, so we need to prioritize wisely what systems we need to take up first, and then build crypto agility by putting the right architecture in place. Like we will be able to transition algorithms smoothly as standards evolve. Like we need to build the crypto agility, so we need to have that architecture in place before yeah, we come across these attacks. And finally, keep monitoring in place, monitor compliance. So keep monitoring compliance, so regulations are moving quickly, so documentation of migration efforts will be essential to staying ahead. Yeah. So those are the key takeaways so far. So so the first session is done. So maybe I'll just take 5 minutes of break. Is that fine, sir? Siraj, sir? So we can just get continue with the rest. Any questions so far? Anyone has on this so far? Whatever topics we discussed. Okay, if I'll take that as no. I'll just be back in yeah few minutes. Right, I'm back. Siraj sir, you can hear me, right? I just need confirmation before we get. Can someone confirm that my audio is clear?
Yes, sir. Your audio is clear. PPTs are visible, sir. Please continue.
Okay, sure. Yeah. So back. So this is the next topic. Like so far, we discussed about the risks and also compliance, regulatory bodies, and all with respect to quantum cybersecurity. But now we are moving on to the next topic. That's leveraging AI and blockchain for quantum resilience. Okay. Now, so let's shift to the two technologies that can strengthen our defenses against quantum threats. Like those two are AI and blockchain. So AI, artificial intelligence, brings speed and intelligence to how we detect and respond to risks, while blockchain provides immutability and trust through distributed records. So, when combined with quantum safe cryptography, these two technologies can give any organization a much stronger security things. So, if you combine these two with the cryptography, quantum safe cryptography is algorithms what we discussed. So, that's going to give more security. So, we'll begin with AI powered cyber resilience. So in modern, right? Even if we do not include that with the quantum, like AI already plays a huge role in a modern cyber security. Like, but in quantum era, it's not yet started, but it's gonna become even more critical. AI can identify patterns in recognizing patterns like amount of uh, it patterns in massive amounts of network traffic that human teams would never catch. For example, like a user logging in at an odd time or unusual data movement. So these can be captured through the pattern recognition. So that can be done with the AI. And behavior analysis, something like it can spot unusual behaviors and it can like machine learning models establish baseline for normal user and the system behavior. So so the accuracy rates also with AI, it's gonna be more than 96%. Yeah, so that's a good thing with AI and behavior analysis. And 0 day vulnerability detection, it can detect anomalies. Uh, I can identify like potential vulnerabilities in code and it can detect the anomalies. They can also learn what a normal looks like and then quickly flag any deviation. If it is something deviating from the normal, then it can just flag and quickly it will flag a deviation. So by applying AI, we can reduce incident rate and also improve the accuracy of alerts and respond to threats that traditional systems allow. So that's what currently AI is doing in this one in threat detection. So we'll see like how what will happen if we use that with the blockchain and also for the quantum era in coming slides. Predictive analysis for quantum era security. So another strength of AI is predictive analytics. Like instead of just reacting to attacks, so it's something. So legacy, what it is before AI, like if any attack is there, then we used to come to know from our information security or team, so that there are an attacks and you need to react. And then but so AI came up with that one. So instead of they reaching us in just reacting to attacks, AI can help us in identifying the risks in first place, like forecasting the risks. So it can simulate weaknesses in existing cryptography and also identify which data sets are most at risks. So what kind of force size or organization can prioritize prioritize remediation steps and address vulnerabilities before attackers have the chance to exploit them. Yeah. So basically it should be like reacting to attacks. Instead of just reacting to attacks, it should be like predictive analytics. Yeah, it should predict that first. So AI driven security automation. So the benefits of AI in security are already measured. Like we have some numbers here. So it's from the market, like the market standards. Organizations using AI have been seeing reductions in the instant fatigue by over 80%, like reduction in alerts. So false alerts are something like, so you'll get an alert, but there is no issue actually. So that is called as a false positive, like false alerts. So that has been reduced, and response times have improved by more than 60%, that's 67%. So this is like responding to any issue happens and all, right? So in few scenarios, like AI can self heal those issues. So that is where like a faster instant response, like it can get the issue and it can fix the issues automatically. So that's also good. And complaints accuracy has, that is also gone up, it's at 91%. And AI ensures like proper implementation of quantum resistant controls and validates conformance. And it saved millions of dollars also. Yeah, security coverage, organizations using the AI about security over more assets with same team size. We don't need the how many people are supporting the security infrastructure with AI. So it's doing many things there, like, so like 3.2x, that's a big number. And if you call check it, that in the resource wise, right? So yeah, all these numbers shows us that AI is not just in a theoretical advantage, it's delivering the real thing there. So it's giving some good numbers in the security area, AI. So I have one case study here, AI enhanced AI powered intrusion detection. So this is an example. So a financial institution, so financial service provider, they deployed an AI-powered intrusion detection. So almost immediately once they deployed it, they saw a false positive drop by nearly 80%, so 79%. So compared to the traditional signature-based systems, and also more importantly, the system detected a sophisticated APT attack that conventional detection for 7 months. So by covering that threat early, the organization avoided like potential damages estimated at over $4.2 million in that prevented loss with this one. So 63% of reduction in security analyst workload. So again, as I said, like manual efforts gonna be lower this, and the 98% faster mean time to detection. Like it will detect like if it captures anything as soon as. So that's so far on AI in cybersecurity, and now we'll just go over like what is blockchain security foundation, so how it is being used. The main feature of blockchain is it in security is like immutable. Like immutable is nothing but it's not gonna change. So once information is recorded on a blockchain, it cannot be changed without our conscious. Yeah, that gives us like tamper proof. Yeah, tamper proof security foundation. Blockchain is a tamper proof security foundation. So think of blockchain as a security book kind of thing. Like every transaction or change is permanently recorded and cannot be erased or modified once it is recorded. So this creates like irreversible distributed verification. Like this creates irreversible trails that can be used for investigation or audits. It also enables yeah, distributed verifications of integrity, meaning so no single party has control over the data, so it is distributed across, yeah, all quantum computers. And For organizations, this translates to stronger protections against tampering and unauthorized changes. So yeah, these fundamental properties like make blockchain an ideal complement to AI systems for quantum era security architectures. Post quantum cryptography integration with blockchain, like as we are discussing about blockchain, this is one of the most promising areas of research, is combining blockchain with post quantum cryptography. So blockchain systems on current status, like currently, they rely on the digital signatures and key exchanges that quantum computers do usually, but that can be break in one day. Like by integrating PQC, like the post quantum cryptography algorithms into blockchain, projects are aiming to make distributed ledgers resistance to quantum attacks. The challenge is here, how about the performance, PQC algorithms performance? They can be slower or more resource intensive, like they may need more resources to run those algorithms, but so the early test or research, whatever is happening, right? So they're showing that this integration is feasible, it can be possible, and but it may need more resources to process that one. So that is the challenge we have. Like 2 to 10x larger signatures. Yeah, performance. All right. Case study: blockchain secured infrastructure. So this is also one of the example what we discussed, like in AI, right? This is one more we have for the blockchain. It's a real world example. So a critical utility infrastructure in energy used blockchain to secure its systems. So there were around 14,000 devices. So yeah, by doing that, they eliminated uh, single point of failure for those 14,000 systems, and also reduced change management risk to zero. And also that's you can say that reduced unauthorized changes by 100% through conscious requirements, and also automated the complaints reporting with provable verification. So that dramatically improved their audit readiness. So as a result, you can see that zero successful attacks since implementation. So with 47% reduction in security operation costs. Like they do not need the security engineers, how many they are operating or they are checking currently. So they got that reduced by 47% with this blockchain technology in their environment. So now this comes like uh, convergence technologies. Like so far, we learned about blockchain and AI in separate terms, but how it works if we combine these two, like AI and blockchain. So we'll just go over like how what feature it's gonna be AI will take care, what the blockchain will take care in this new era. So AI detection system, so AI monitor systems, and it will just look for the threats, look for the vulnerabilities, including the potential quantum based attacks, what we are going to talk, like what we are going to expect in near future. So those events are immediately logged into the detected by AI, and it's logged into the blockchain, ensuring they can't be alerted once it is been moved to blockchain. So it will just detect, or they are immutable, something like it's not going to change with until and unless conscious validation to prevent the attacker manipulation. So attacker can't do anything once when it is moved to blockchain technology. So smart contracts then triggers an predefined responses. So automated, like tamper proof and automated responses And finally, AI reviews the results and improves uh, for the next time, like adaptive defense, like AI analyzes the response and uh, for improve future security measures, right? So and the results also in if anything, something can be self-healing, it can be done. AI can do that one in this area, like adaptive defense. Like if something they can fix, that will try to fix, and it will just keep learning from the instance which attacks which is happening, and it will just get better from the whatever instance occurred. So that's adaptive defense. Technical architecture, a blockchain security platform. So from technical perspective, so we'll just think of it in three layers. Yep, data layer, processing layer, response layer. So in first the data layer, secure data ingestion, like it's quantum resistant encryption and also distributed storage across across multiple storage devices and all. Processing layer, like AI engines, like ML interface engines, AI engines, what we're gonna use, and consensus mechanisms like blockchain consensus mechanisms and smart contracts doing the heavy lifting, like it's moving that way again. Yeah, so that is a processing layer. And response layer is like it's automated mitigation. Again, AI is the key here in the response layer, automated integration and orchestration services and human in the loop interfaces. Like we need to, so we can't depend 100% on AI, right? Like we need to look after results, overseeing when it needs, like once a process or reacts to your alerts or threats, then we need to review this also. So that's then the response layer. So this layered approach, data layer, processing layer, response layer, so this approach provides both flexibility and resilience. Yeah. So the future outlook, how it's gonna be in quantum resistant cyber ecosystems. Like the looking at the future, like we are moving towards the fully quantum ecosystems, quantum resilient ecosystems. So that means we need to adopt all these like post quantum cryptography standards. So as I said a couple of times, NIST is finalizing that algorithm, uh, post quantum cryptography standard algorithm. So once it is finalized, we need to implement across the AI blockchain platforms and shifting to decentralized security governance, industry-wide security protocols managed through the governance and autonomous organizations, and enabling the self-sovereign identity systems. So quantum resistant authentication without centralized identity providers. And finally, uh, fully autonomous security operations, AI driven security with minimal human intervention. So yeah, as I said in my previous slide, we need human intervention, even if it is driven by the AI also. So and also continuously adapting to the new threats. So this whole cycle looks like a futuristic cycle, but these ideas are already being tested today. So and the vision is security systems that does not just react; it adapts continuously. So if you want to move to this AI, blockchain, and the uh, quantum cryptography mechanism, like post quantum cryptography standards, so what is the roadmap, like how long it will take and all, right? So we'll just give rough estimated timelines. uh, this requires a roadmap, like as we discussed earlier. In for other roadmap, in phase one we are going to do the assessment. So this is going to take 3 to 6 months. So we're going to look for the mapping vulnerabilities and identifying where AI and blockchain can help. And moving on to phase 2, pilot implementation. This is going to be 6 to 9 months usually. So testing AI detection and blockchain logging in high value areas. And phase 3 is integration, connect AI and blockchain components, and also implement quantum resistant algorithms, the quantum cryptography algorithms, and also develop autonomous response capabilities. So that's for self healing here. And phase 4 is scale. That's about 12 to 18 months. Like once you are done with your integration, we need to deploy it across your organization wide. So because we discussed earlier that low risk, high risk, medium risk assets, right? We need to deploy across all the systems. So cross organization security sharing and continuous optimization and refinement. So it's a step-by-step journey, so it's not going to happen on one day. So it needs some time to implement the this AI blockchain and cryptography algorithms. Key success factors, technical consideration for success. Yeah, we have two technical and organizational considerations. So technically, we need cryptographic agility, like the ability to switch algorithms as threats coming up, new threats coming up, and we need performance optimization. So security does not slow down operations. Like we need, so because we are processing all these on your infrastructure, right, on your organization, so it should not impact your performance of your applications or your deliverables. So that we need to check here. And the integration architecture, so it develop clear APIs between AI and blockchain components to maintain separations. Yeah. So you need clean integration between AI and blockchain there. Organizational, we need skill resources, skill development, invest in training security teams on quantum computing, AI, and blockchain fundamentals, because those are the new emerging technologies in security area. So organizations should invest on skill development and governance models like oversight of autonomous security systems with appropriate human controls. Governance models we need to look up there. Clear governance should be there, and updated risk frameworks. We need modify security risk assessments to account threats for AI and blockchain controls. So it's not about a technology here. So security is not about technology. It is all about people, policies, and processes. So those are all the key success factors. And we come to the last slide summary, the quantum resilience security posture. So just to summarize, AI brings advantages in adopting and in prediction and in automation and also in self healing the issues. So that AI brings those advantages. Blockchain advantages, or it brings trust, that is with the immutable security audit and distributed trust and verification, and also transparency. And that's with the quantum rest and infrastructure. Yeah. And if we include these two, then the combined benefits are like self-healing. We discussed that one, self-healing security architecture, reduced human error vulnerability, like we are gonna reduce the human efforts itself. So the error rate also will go down, and future security investments, future-proof security investments. So the organizations that start preparing today, uh, using AI or blockchain into their defenses, will be the ones ready for the quantum era. It's gonna come up soon. The quantum era. Yeah. All right. I'll just talk about the quick takeaways from today's sessions. So quantum computers will break the today's available encryptions. So readiness is mandatory and it is urgent. And risk management gives us a structured way to prepare that we discussed a cycle called identify, assess, mitigate, and monitor. And compliance requirements are emerging, and this will be soon mandatory, not an optional. And most practical solutions are like NIST provided, NIST approving post quantum cryptography and crypto agility are the practical solutions. So early action reduces risks and it lowers cost. Yeah. So one simple message there is like organizations, like companies, whatever it is, like must begin preparing for the quantum future now. Mostly the financial or government healthcare sectors, they should be preparing for this now. I think that's it I have for the session. And any questions? I'll take any questions if you have any.
Dear participants, if you want to ask any questions to the speaker, please unmute yourself and you can ask the questions. So I think
No questions. Okay, I'll consider that as no. I think that's it then. Thanks all. Thanks for your time and attention. I hope the session is useful for you. At least it gives some information about the uh, this new technology or new what we are going heading with the quantum and with help of AI and blockchain. Yeah.
thank you, sir.
Thanks all.
Thank you very much. Thank you very much, sir. Your session is very informative, sir. It's definitely useful for our career as well as in our research. I'm sincerely thanking you, sir, for sharing your valuable insights into this burning topic. Thank you very much, sir.
Thank you. Thanks, Siraj sir. Thanks. Thanks all. Nice session. Bye.
Thank you, sir. Bye-bye. Bye-bye, sir. All the participants, today's session feedback link is available in chat box. Please click that and submit. I'm repeating, dear participants, today's session's feedback link is available. Please click that and submit. We will start the session within next session will be started in 5 minutes.
Once again, all the participants, let me take privilege to invite our esteemed speaker. We already well known about session on day one. I would like to invite Mr. G. Anil Kumar Garu, data analyst, Elite Idea Solutions India Private Limited, senior analyst, talented speaker. I would like to invite. Thank you very much, sir, for being second time in this faculty development program. Thank you very much. Sir, please start your session, sir.
Thank you, sir. So, good evening, everyone.
Yes, sir. Yes, sir. Good evening, sir.
So, today in this FDP, we will discuss
Good evening, sir.
Good evening, madam. Good evening, everyone. Sir, can you please allow to share my screen?
It is already allowed, sir. You can share.
No, sir. You are not allowed to share your screen. Showing
One
like
second. Sir. 1 second. I will check it once. I will check it once.
that. Okay, sir.
Yes, sir. Now you can share your screen, sir.
Okay, sir. Sir, is it visible? Hello.
No, sir. PPT is not visible, sir.
No, sir, it's not visible.
Wait, madam. I will join through Chrome. So, in Safari, it is not showing.
That's okay, sir. Fine.
Hello. I am audible.
Yes, sir. You are audible, sir.
Okay, so now I'll share my entire screen, sir. So you please tell me whether it is visible or not.
Sure, sir. Sure.
Sir, is it visible?
Screen is visible, sir. Still PPT is not open.
సో మ్యాథ్ ఓపెన్ చేసా ఇగో మ్యాథ్ ఓపెన్
see now it is visible. PPT.
Yes, sir. It is just visible, sir. Visible. Yes, sir. It is now okay.
Okay, screen slides are changing.
Yes, sir. Changing, sir. Fine.
Hello. Okay, so in this FDP, today we will discuss about policies and governance and ethics in a quantum security. In a previous FDP, I explained about what is the quantum technologies, what is the quantum computing in coming generation, how it is helpful, and what is the impact of quantum computing. So we already discussed all those things. So, uh, so to develop anything compulsory, we need some policies, and we need to follow some guidelines, as well as we need to follow some rules, and we need to implement some rules, and we need to follow some ethics. So similarly here also for quantum security, we need to follow some policies, as well as some governance related rules and ethics. So coming to a policy, policy is a set of rules or a principles, or I already told guidelines. Okay, so these are made by the government or any organization or institutions. For what purpose we follow these policies means to take a decisions. For that purpose we use these policies. So policies include in education or healthcare. Also, we are using policies in our quantum security. So the main intention of quantum security is to provide a better security in a quantum technologies or a quantum computing. Okay, so coming to governance is nothing but it is a process of decision making and implementation of policies. So we discussed policies. We provide some guidelines in the form of policies. So we need to implement those policies in a governance. So here in governance, so many organizations will form and they will implement each and every policies. Coming to ethics, ethics is nothing but what here compulsory ethics is important, means what we are suppose if you do anything wrong, suppose if you do anything right, so wrong and right both comes under ethics. So here we will discuss about these three in our quantum security. So see, preparing your organization for the quantum revolution requires understanding not just the technology. Okay, so here we no need to understand the technology, and that is not sorry. Prepare your organization for the quantum revolution requires understanding not just the technology. So understanding is okay, no need of technology, but the emerging policy landscape that will shape how we implement quantum safe security. So because of these policies, how much security we are providing to our quantum technologies, that will indicate these policies and governance and ethics. And these three are the major part for anything, not only for quantum security. So we can apply these policies, governance and ethics for any product. So next, today's FDP, our agenda is the quantum security landscape, the evolving threats, stakeholders, and the core challenges. So means how we are providing this security. So we will explain in first agenda. So next, global regulatory frameworks, in that national initiatives, standards, bodies, and compliance requirements. So the third one is governance best practices, building quantum resilient security governance models, how we are providing different kinds of securities models in our quantum computing. So next, ethical considerations, what type of ethical things we are using in our quantum security, we will explain in this ethical consideration. So balancing innovation with responsibility. So compulsory we need to balance our innovation with a proper responsibility, that we will discuss in ethical considerations. So coming to the last one is action plan, implementation strategies and next steps for your organizations. So how we are using these things in our organizations, how we are implementing this quantum security or quantum computing in our organization or our institutions, that is comes under action plan. So that is the next step for our organizations. So I means here which strategies we are using, what strategies we are implementing for quantum computing. Sorry, for a So coming to the first one, the quantum revolution. So here the stacks and stakeholders will be present in this revolution. So the quantum computing promises unprecedented computational power, but threatens our current security infrastructure. So it provides a rapid computational power, and it provides a fast calculations, and it provides a fast computing. So means it provides a better computing with compared to the classical computing. So we already discussed about these classical computings in a FDP, first day of FDP. So while when compared to the classical FDP, sorry, while compared to the uh, classical computing, so the quantum compute is very fast, and it do the calculations quickly, and the computational power is also too high. But there is a chance to threaten for the security. Maybe so many attacks will happen to our quantum security. So that we need to solve, that we need to take as a challenge, and that we need to provide a better securities to quantum computing. So that we will do in our quantum technologies. So here the challenge isn't just a technical, it's organizational, political, and ethical. So here the challenge not a technical challenge, it's just not a technical. So we can it is maybe an organizational challenge or a political challenge and ethical challenge. So coming on to securing our quantum feature requires coordination between. So if you want to provide a proper security to our quantum computing, compulsory we need certain requirements, and we need certain coordination from the other people. So the coordination is where we are getting this coordination. So from the government agencies and regulators, we'll get the we need a coordination, and we need a cooperation to provide a security for our quantum computing. And standard bodies like NIST, ISO, and ETSI. So from these also we need some coordination to provide a security for our quantum computing. So also industry leader support we need, and technology provides support, coordination also we need. Coming to security researchers and academic institutions, coordinations also important for securing our quantum features. And end user organizations across all sectors who are using these quantum securities, those comes under end users. Next, why security needs policy frameworks. So we are providing a security to our quantum computing, our quantum technologies. So then but then what is the need of policies we need to use? What is the need of policies? So the policies is very important, means in which manner we are providing a security, and what guidelines we are using for providing a security. So that all those things are very important. For that purpose, the policies is very important in a quantum security. Okay, so uh, so here you are seeing these four are the main things to provide a uh, these four are the main needs of are the policies. So the first one is protect critical infrastructure. So we need to provide a we need to protect a infrastructure, means vulnerable sectors like finance, healthcare, and utilities need coordinated protection strategies. So compulsory we need to provide security in finance and healthcare and utilities need coordinated protection strategies. Why we need to provide why we need to protect the security in this critical infrastructure? Suppose so in our quantum security we are providing more security to our data. So in healthcare and finance we have so much of data is there. So and that data is a confidential and sensitive data. So for that purpose we need to provide a better security to the critical infrastructure in healthcare and finance. So we are providing security to our data. So, and if we provide a more security, and that should not be a breakable one. So, in a classical computing, maybe it breakable with certain attacks. So, whenever we are using quantum security, so it should not be breakable. Okay, so that much of security we are providing in a quantum computing and a quantum technologies. So that's why. So this is also one of the main reason. This is a very important in our future generations. So maybe in our seventh generation of computers or eighth generation of computers, we will see all these quantum related topics only. So next one is ensure market adoption. So standards drive interoperability, enabling widespread implementation of quantum safe solutions. So we need to implement fast solutions for fast quantum safe solutions in a market adoption. So the next one is prevent security disparities. Okay, we need to provide certain security related things. So in our quantum security, here, policy frameworks help close security gaps between organizations with a different resource level. Suppose let us consider an example related to an organization. So in that organization, there may be some security errors or security issues are there. So with the help of this prevent security disparities, we will close that security gap with our quantum computing or quantum security. So with that, we can provide or we can prevent the security in that organizations. So coming to the last policy need of policy framework in a quantum security is manage the transition. So in this coordinated timelines and requirements enable smoother migration to a quantum resistant system. So this is the last need of quantum computing. So quantum security policy framework. So in this we need to follow the timelines, proper timelines, and we need to use a proper requirements for enable smoother migration. Migration means we need to transfer the data in a secure manner. So without strong policy frameworks, our quantum security landscape will be fragmented, inconsistent, and vulnerable to exploitation. So if we want to provide a strong policy framework, so our quantum security will be fail. Okay, so it is not a good in a future. So that is the last line meaning. And if you want to use a strong policy frameworks, it may chance to attack more more attacks. The next one is global regulatory landscape. So quantum security policy is evolving rapidly across jurisdictions are creating a complex global landscape that security architects must navigate. Okay, so here, so the quantum security policy is nowadays it is rapidly increasing, and it also navigation. It also gives the navigation to our security architects. So maybe with the help of this, they will provide a better securities. So that's what it is. So the quantum security policy is evolving rapidly, means it is nowadays it is increasing rapidly, it is growing fastly. The key differences include implementation timelines in that varying deadlines for a quantum safe migration, and technical requirements, different cryptographic algorithm preferences we are using in a technical requirements for a better security. So here cryptographic algorithm, for what purpose we are using means we are using these cryptographic algorithms for a better security. Okay, so in this we may use encryption and decryption algorithms for a security purpose. So the scope of regulation, which sectors and systems must comply. So, and means in which sector we are using this quantum security, that is a comes under scope of regulation. So enforcement mechanisms means how compliance is verified and penalties for a non-compliance. Organizations operating globally must reconcile these differences in their security strategies. So this is a US quantum security initiative. So this comes under a governance, means some countries or some organizations combined together. They will implement our policies. What we provided in a previous, they will implement each and everything. They will take the decisions in a better way. So not only one country, maybe sometimes other countries also include in a governance. Government also included, and other third party persons also included in the governance. So they will take the decisions based on the policies. So this is the US quantum security initiatives. So in this NIST PQC standardization, so here selecting and standardizing quantum resistant cryptographic algorithms with first standards published in a 2022. So here we are selecting different kind of cryptographic algorithms with first standards published in a 2022. So means here we are selecting a proper algorithms for a security purpose. So next, National Quantum Initiative Act. So in this, $1.2 billion investment in a quantum research, development, and workforce training. So why this much of investment they are investing means? So this is a very good concept, and also it is very helpful in our future. So with the help of this quantum computing or quantum technologies or quantum security, so lot of things will we can do in easy manner. So next, NSM 8 memorandum. So direct federal agencies to inventory cryptographic systems and prepare for a transition to quantum resistance cryptography. Next, Quantum Computing Cybersecurity Preparedness Act. So this is one of the act related to quantum computing cybersecurity. So requires agencies to prioritize migration to post-quantum cryptography. So here agencies requires to prioritize migration. So means transferring to post-quantum cryptography. So this is related to European Union Quantum Security Framework. So how they are providing a security. So in that, the Digital European Program, a 7.5 billion investment in a quantum technologies and cybersecurity resilience. So they are investing 7.5 billion. So here they are investing 1.2 billion. Sorry, dollars. So next, European Quantum Communication Infrastructure, EuroQCI. So building quantum secure communication network across all member states. So here we are talking about quantum secure communication. Means this is related to a network side. Okay. So how we need to provide a security in a networking while transferring the data, so that it will indicate that is nothing but a quantum secure communication. So the communication in a network, it is also in safe manner and in secure manner. That should be a mandatory. So that is nothing but a European quantum communication infrastructure. By this, they will communicate in a proper way while transferring the data, means in a secure way. NIS2 directive expanded cybersecurity requirements, including quantum readiness for a critical sectors. ENISA quantum guidelines. So these are related to ENISA quantum guidelines, technical recommendation for a quantum safe migration and implementation. So here is the, if we want any technical recommendation for a quantum safe migration, so and implementation purpose, they will provide guidelines. So this is related to Asia's Pacific quantum security policies. So before the European Union related security framework, these are the US quantum security framework, and this is related to our Asian side. So in Asian, here the first country we are The first country is China. So in China, 14th 5-year plan prioritizes quantum technology and security. So here, their 5-year plan is nothing but a quantum technology and security. So they are investing 10 billion national, sorry, 10 billion, $10 billion national laboratory for a quantum information sciences. So for their research work, they are investing that much of amount. Next, developing China-specific PQC standards potentially incompatible with the Western approaches. So they are implementing related to their kind of strategies. They they may be sometimes incompatible with the Western approaches. So coming to Japan, so quantum technology innovation strategy with a 30 billion annual investment. They are investing 30 billion annual investment to develop quantum technology innovation strategy. So NICT leading quantum cryptography standardization. They are using the standardization, that is NICT standardization. So coming to India, in our India, national mission on quantum technologies with 1.12 billion dollars funding means they are investing in our India. So focus on indigenous quantum safe cryptography development. They are focusing on this quantum safe cryptography development. So this is nowadays ongoing process in India. So coming to Australia, so national quantum strategy emphasizing security applications. So, so ASD guidance on a quantum resilient cryptography for a critical infrastructure. They are working on this ASD guidance on quantum resilient cryptography for a critical infrastructure. So Asia Pacific approaches emphasize technological sovereignty and independent standards development, creating potential interoperability challenges. So, to create a potential interoperability challenging and a better development, these Asia Pacific countries are using these quantum securities in their research. So next, global standard bodies shaping quantum securities means what type of standardization we are using uh, for a quantum security. So these are the some standardizations we are using to provide security in a quantum computing. So here NIST. So leading PQC algorithm standardization, primary reference for a most national frameworks. So NIST is one of the standardization we are using leading PQC algorithm standardization it is. So primary reference for a most national frameworks we using this NIST. So uh, ISO or IEC. So it is used for developing international standards for a quantum resistance cryptography. So ISO IEC 23837. So this is a standardization. So for what purpose we are using? So we are using to develop international standards for a quantum resistance cryptography. So for that purpose, we are using this ISO by IEC standardization. Next, ETSI. So European standards for a quantum safe cryptography implementation and migration. So for this purpose, this implementation and migration purpose, we are using this ETSI. So the last standardization is ITU-T, Global Telecommunication Quantum Security Standards and Recommendation. For a better communication purpose, we are using this standardization. So these bodies are working to create interoperable standards, but divergence remain. Organization should monitor all relevant standards while prioritizing those with the regulatory force in their operating uh, jurisdictions. Next, these are some legal and compliance challenges in quantum security. So quantum security at the intersection of multiple regulatory domains. So these are some of the challenges. So data protection laws, so and cross-border requirements, financial regulations, healthcare compliance, critical infrastructure. Uh, these are the some challenges. Coming to data protection laws, GDPR and CCPA and similar regulations require maintaining data confidentiality through a cryptographic transitions. If we use a cryptography algorithms, compulsory we need to provide a confidentiality to our data. So that is the one of the challenge. Uh, and next, coming to cross-border requirements, data uh, sovereignty rules complicating global quantum security implementation. So these rules are complicating global quantum security implementation. So this is also one of the challenging for providing a quantum security. So next, financial regulations. SEC, Federal Reserve, and international financial authorities establishing quantum security requirements. So this is comes under financial regulations. So next, healthcare compliance. So HIPAA and international medical data protection laws requiring a long-term encryption security. So compulsory in healthcare also we need to provide a better security. In healthcare and financial concepts, we are using we are providing we are protecting our data. So the main intention of these in these two, we need to provide the protection for our data. So that is the main thing in healthcare and financial. Next, critical infrastructure. Sector-specific regulations for energy, utilities, transportations with varied quantum security mandates. So in a critical infrastructure also compulsory we need to provide a better security. With that, data won't loss. Coming to the crypto agility imperative. So crypto agility, the ability to rapidly transition between cryptographic algorithms is becoming a regulatory requirement across multiple frameworks. So crypto agility, it is nothing but it is an ability to rapidly transition between cryptographic algorithms. So it provides the rapid transition between cryptographic algorithms and across multiple frameworks. So it is becoming a regulatory requirement. So it is one of the main requirement in a quantum security. So why it matters? Then what is the need of this crypto agility? So standards are still evolving and may change. So algorithm vulnerabilities may be discovered. If is there any problems or is there any errors will occur in algorithms, they may discovered easily. Different jurisdictions may require different algorithms. Okay, so then what is the next thing is for why it is matters. Hybrid approaches are needed during transition periods. Hybrid approaches means we need to use different kinds of approaches, not only a single approach. We need to use two or more approaches. That is nothing but a hybrid approaches. For what purpose we are using these hybrid approaches are needed during a transition periods. So for a better security purpose only. So regulatory trend, frameworks increasingly require demonstrable cryptography as a part of security governance. So we are talking about the cryptography. Cryptography means it, because of this only we are providing more security in a quantum computing. Uh, Building quantum resilient security governance. How we are building this quantum resilient security governance? With these steps, we will build the quantum resilient security. So these are the decisions to build quantum security. So the first one is quantum risk assessment. identify cryptography assets, prioritize systems based on a quantum vulnerability and sensitivity. So first we need to identify the risks where we are getting all those risks. So then we need to do the policy development. So based on that, we need to write the guidelines for those problems. Okay. So policy is nothing but we need to provide a guidelines, or we need to provide some solutions to the what are the problems or what are the issues we are facing with the current thing or current what issue. Okay, so for that issue we are providing different kinds of guidelines. So those guidelines or principles, we are calling it as a policy. So after identifying the risk or after identifying the issue, so we need to provide some policies. So that is nothing but a policy development. So here, create a quantum specific security policies aligned with the regulatory requirements and standards. Based on that regular requirements and standards, we need to design our policies. So after designing the policies, we need to take the decisions based on the policies. That is the comes under governance. So the next step is governance structure. So establish clear roles, responsibilities, and reporting lines for a quantum security. Means we need to establish what are the roles and what are the responsibilities. So everything we need to design in a governance structure. Means we need to give a proper instructions based on the policies. So that we will do in a governance structure. So next, migration planning. So develop phased implementation roadmaps with a compliance deadline. So after governance structure, we need to do the migration. So means we need to transfer our data. So next, monitoring and compliance. So after migration, we need to monitor the data, and we need to monitor the entire our quantum security, whether it is working fine or not. So implement ongoing assessment of quantum read lines and regulatory alignment. So effective governance requires a cross-functional collaboration between security, legal, compliance, and IT teams. So these are the some building steps to provide a quantum resilient security governance. The next is role of governance in a quantum transition. So what is the role of governance in the quantum transition? Means in a quantum transition, what is the main advantage of governance? What is the impact of governance in a quantum transition? So how it is helping in a quantum transition, so that we will discuss in this. So without strong governance and with effective or with strong governance, what is the difference we will see. So fragmented reactive implementation approaches is there without a strong governance. Inconsistent security levels across system means there is no proper security. Compliance gaps and potential regulatory penalties means security gaps will be present. Higher transition cost due to duplicated efforts. So if there any duplicated data, so maybe the cost is also high. So while transferring the data. So extended vulnerability periods during a transition, there may be a chance to get more errors. So that is the last one. So if we provide a governance, means if we provide a proper structure, so with effective structure, what will happen? Coordinated strategic implementation across the systems and consistent security posture aligned with the risk tolerance. So, and here we are providing a good security with the help of effective governance. Proactive compliance with evolving regulation. So the compliance, there is no gaps. Here we will solve the gaps. Optimized resource allocation based on priorities. Resources also allocated in a better way, in a proper way. Minimize disruption during cryptographic transitions. So here we can minimize the any disturbance will happen. So we can easily minimize those disruptions. The next is ethical dimensions of a quantum security. So before that, we seen what are the policies we seen, what are the governance, how it is be helpful in a quantum security. We already discussed. Policies is nothing but means I already told policies is nothing but a guidelines or principles. Coming to the what governance is nothing but how to follow those policies. It will how to take the decision based on policies. That is nothing but a governance. That means simple terms. So coming to it now, the last one is ethical dimensions of a quantum security. Means after, by this we will see related to ethical concepts. Means ethical means trust or not trust. Maybe it will come. Means a good or bad. So in ethical, we will explain about what is a good in a quantum security and what is a bad. So that is comes under ethical dimensions of a quantum security. So how much we can trust this quantum security? So that is also sometimes maybe comes in a ethical part only. So access equity. So means preventing a security disparities between resources, rich and resource constrained organization. So next, responsible disclosure, ethical handling of a quantum vulnerabilities and exploits. So the next one is privacy protection. Means we need to provide a better privacy for our sensitive data. So maintaining confidentiality of sensitive data through the quantum transition. To the quantum transition, we need to maintain our data in confidential way. So that is comes under a privacy protection. So and for that we need trust is important for a confidential purpose. Next, global inclusivity. So ensuring international perspectives are represented in a standard development. So next, transparency. So transparency may be a trust. So we need compulsory trust. So open communication about quantum risk and migration strategies. So while transferring the data, so trust is also very important. Without trust, we can't do anything. So that maybe the data we cannot send. Ethical consideration should be explicitly addressed in a quantum security governance frameworks, not treated as an afterthought. Okay, so these are explicitly addressed in a quantum security in a governance frameworks. Next, balancing innovation and security. So means how we will balance the innovation and security at a time. So compulsory we need to balancing the innovation and we need to provide the security. So if we balance only innovation, so if we won't provide security to that innovation, so that innovation, the developing of that innovation is waste. So if our innovation is not good and we are providing a security that innovation, so that is also not a good thing. So that is also failure thing. So compulsory we need to balance both innovation and security in a same level. So that it will indicate. So here balancing and innovation, balancing innovation and security. The quantum revolution presents a policy paradox how to encourage technological advancement while ensuring security and ethical use. So if we use ethical concepts and ethical things, we need to ensure the security as well as we need to balance the innovation also. Innovation drives and security imperatives. See, so coming to innovation drives, research funding and incentives, public-private partnerships, commercialization pathways, open knowledge sharing. So these comes under innovation drivers. So coming to security imperatives, so risk management frameworks, so regulatory compliance, critical infrastructure protection and privacy safeguards. See, in security imperatives, compulsory we need to find out the risk and we need to solve that risk. So regulatory compliance also important. Means critical infrastructure protection. So here the critical infrastructure means in organization or healthcare or financial, the main critical infrastructure is data only. So we need to provide a good protection to that data. So that is comes under security imperatives. So and privacy safeguards. We need to provide the privacy also for that data, means confidential. The data should be in a confidential manner. Effective policy framework must balance these competing interests without without unduly sacrificing either innovation or security. So if we use a proper effective policies, there must balance innovation and security at a time. So that is the last line meaning. So the next thing is industry initiatives and self regulations. So coming to industry consortia leading quantum security, come in self regulation approaches. How it will be? See, Quantum Economic Development Consortium (QEDC), industry-led group driving quantum technology standards and adoption. So these are the some industry initiatives and self-regulations. So coming to the industry, the first one is Quantum Economic Development Consortium. So in that industry, lead group driving quantum technology standards and adoptions they use. Cloud Security Alliance's Quantum Safe Security Working Group. So developing best practices for a quantum safe cloud migrations. So in a cloud, we will transfer the data. So there we are using this quantum security. Next, World Economic Forum's Quantum Security Network. So public-private partnership addressing quantum specific policies. So coming for a quantum safe products. Okay, so these are the vendor certifications for a quantum safe products. Industry specific frameworks. So here we use some industry specific framework like financial services or quantum drawn exercises. So next, open standards development through a community driven initiatives. So these comes under self regulation approaches. The next thing, quantum security governance for your organization. So this is a quantum security governance for our organizations or for our institutions. So means where we are using. So the first one is policy development is important, organizational structure and compliance management and vendor management. So these four are the important things for a quantum security governance in our organizations. So coming to policy developments, compulsory we need certain rules and principles. Then only it will be okay. So if you won't follow any rules and any principle, so it's not good. So create dedicated quantum security policy means we need to create a better dedicated policy, quantum security policy. Update existing cryptographic policies to include quantum considerations. So means we need to update the already existed cryptographic policies. So with including quantum considerations. So by including quantum considerations, we need to update our existing cryptographic policies. So next, define quantum risk tolerance aligned with the business objectives. So we need to define the quantum risk tolerance also with the business objectives. So next, compliance management. Monitor emerging quantum security regulations. We need to monitor all the quantum security regulations. Map requirements to specific systems and processes. So we need to provide a good mapping for our requirements and processes. Develop compliance validation and reporting mechanisms. So we need to develop a compliance validation and reporting mechanisms. So in a compliance management. So next, organizational infrastructure. So in organizational infrastructure, establish quantum security steering. We need to establish one committee. So that committee is related to quantum security steering committee. So designate a quantum security officer or equivalent role. So we need to give a one designation for that an officer, that is nothing but a quantum security officer. So define cross-functional responsibilities and accountabilities. So we need to provide some cross functional responsibilities to that designated person. Next, vendor management. In vendor management, update procurement requirements for a quantum safe products. We need to update these requirements for a quantum safe products. Next, assess vendor quantum security roadmaps. We need to assess what are the vendor security quantum security roadmaps. That also we need to do in a vendor management. Next, include quantum requirements in a contracts and SLS. The next thing is implementation roadmap. How we will implement these quantum security. How we will establish this quantum security. So for that purpose, this is roadmap. So if you want to develop immediate, means 0 to 6 months, establish quantum security governance team. We need to establish the quantum security governance team and conduct cryptographic inventory and risk assessment and develop initial policy framework. So if you want to implement within a short period, means immediate, that is nothing but 0 to 6 months. So compulsory we need to establish a quantum security governance team first. Then after we need to conduct cryptographic inventory and risk assessments. So means what are the problems we need to identify first. After that, we need to provide the policies for that problem. So we need to develop the policies policies for that problem. So that we can do in a 0 to 6 months for immediate roadmap. So if that is near term, means 6 to 18 months, means 1.5 years. So began cryptographic agility implementations, pilot PQC in non-critical systems, develop comprehensive compliance strategies. We need to do all these things in 6 to 18 months. Next, midterm, 18 to 36 months, implement PQC in priority systems. So in priority systems, we need to implement PQC in a priority systems. This is not in 18 to 36 months. This is an implementation of 18 to 36 months. So in that, first we need to implement PQC in a priority systems. So develop transition plans for legacy systems. Integrate quantum security into enterprise risk management. So the next is long term, means 3 to 3 means after 5+ years. So this is nothing but a long term. If you want to implement quantum security in a long term, okay, so for that purpose we need to use this roadmap, this implementation roadmap. So long term, so complete PQC migration for all systems. We need, so in a previous midterm, so we are implementing PQC in priority systems, means certain systems only. So here we need to migrating for all systems. So we are completing all the systems in long term. So establish continuous quantum threat monitoring. So we need to establish the continuous quantum threat monitor, means we need to monitor the each and every threats in a continuously. So for that purpose, we need to establish a continuous quantum threat monitoring. Prepare for a next generation of quantum security challenges. If in future is there any challenges will occur, we need to also prepare for that challenges. Your timeline should align with both regulatory deadlines and your organization specific risk profile and system critically. These are the some key takeaways. Regulatory landscape is rapidly evolving. So governance is as a critical as a technology. See, regulatory landscape is rapidly evolving. So national and sectorial quantum security regulations are developing quickly but unevenly across jurisdictions. So next, governance is as critical as a technology. So governance is also critical as a technology. Effective quantum security requires robust governance frameworks, not just technical solutions. So we need to provide a robust governance, means a strong governance framework for a security purpose we need to provide. Next, crypto agility is a core requirement. So regulatory frameworks increasingly mandate the ability to rapidly adapt cryptographic implementations. We need to implement cryptographic concepts rapidly. Cross-functional approach is essential. So cross-functional approach is also essential. Quantum security governance spans technical, legal, compliance, and business domains. So these are the some cross-functional approaches. Next, these are some next steps. How we can access, how we can plan, and how we can act. Inventory cryptographic assets. So So means develop governance framework. So establish steering committee. So map applicable regulations, create policy documentation. So assess inventory, cryptographic assets, map applicable regulations, evaluate current governance, identify key stakeholders. We need to do all these things. We need to inventory cryptographic assets and map applicable regulations, evaluate current governance. We need to evaluate what is the current governance, means current decisions. Next, identify key stakeholders. Then in a plan, develop governance framework. We need to develop the governance framework based on the policies. Create a policy documentation. After that, we need to create a entire policy documentation. Next, define roles and responsibilities. Means we need to allocate some designations to the persons. Means that is nothing but a role allocation and responsibilities allocation. So build implementation roadmap. So we already seen all these things in our previous slides. We need to build a roadmap. We need to select whether it is a immediate or midterm or long term. So that we need to select. So next, act. Establish steering committee. We need to establish one committee. Initiate crypto agility projects. Engage with standards bodies. Begin vendor assessment. So these are some next steps. Assess, plan, and act. Next, global quantum cryptography standards and policies and ethical frameworks. So these are, now we are talking about global quantum cryptography, in that standards, policies, and ethical frameworks. A comprehensive exploration of the international standards, geopolitical dynamics, and ethical considerations shaping the future of quantum resistance cryptography. So how these are useful to shape the quantum resistant cryptography. The international standards ecosystem. So we already seen all these things. Here the new one is IEEE. So ISO, IEC we already seen. So JDC1, SC27 developing standards for a quantum resistance cryptography under ISO IEC 15408 for a security evaluation criteria. Based on the security evaluation criteria, so we are developing standards for a quantum resistance is JDC1 by SC27. So this is one of the international standard. And ITU focus a group on quantum information technology, creating a recommendations for a quantum secure communication infrastructure. This used in a communication purpose. Next, ETSI. So quantum safe cryptography, working a group advancing standards for a quantum resistance algorithms in a European networks. The next standard is IEEE. So P1913 working group establishing software defined quantum communication protocols for a networking system. So for networking systems, they implemented or they established a software defined quantum communication protocols. So these are the some international standard ecosystems. The critical need for global interoperability. Quantum secure systems must operate across borders and between organizations with a different technical and regulatory requirements. So the next, multi-cloud environments require consistent security implementation across the providers. So here the multi-cloud environment requires for what purpose? Consistent security implementation. So we need to provide the consistency security to each and everyone. So it means across all providers who are using the cloud services. So we need to provide the consistent security. So means we cannot provide more security for one user, low security for other user. So we need to provide a consistency in a security to each and every cloud access cloud providers who are accessing cloud. Supply chains depend on compatible security protocols between our partners. Financial transactions need standardized quantum security across jurisdictions. These are the NIST standardized post-quantum algorithms. We already discussed about these algorithms in our first day of FDP. So Kyber, dilithium, Falcon, and SP Sphinx. So these are the algorithms. These are the standard post-quantum algorithms in a NIST. So Kyber and dilithium and Falcon and Sphinx. These four are the algorithms we are using in a quantum computing. Next, international algorithm adoption landscape. So in that NIST alignment, and what are the alternative approaches? EU's means EU's PQ crypto project directly integrating NIST selections into recommendations. So Canada's CCCS advising adoption of NIST standards with a Canadian specific implementation guidelines. So based on their guidelines, they are using different kinds of NIST standards. Australia's ASD formally endorsing NIST algorithms with a local security review. So these are the NIST alignments in a different countries. So what are the alternative approaches? In China, SM cryptography series developing independent algorithms, SM9PQ rainbow variants. So in Russia's Stribog based implementation prioritizing sovereign cryptography they are using. And India developing hybrid classical quantum approach for a phased transition. In India, we are using this approach in a quantum security. Next, implementation guidelines, implementation timeline in a global variation. So we already seen same content and same diagram in a first day of FDP. In 2023 to 2024, how it is there. In 25 to 2027, how it will be there. After 27 to 2030, so how it will be. And 2030 to 2035, how we are providing more security with the help of quantum computing technologies. So that it will indicate. Next, interoperability challenges. So parameter sets and encoding formats and algorithm agility. So in parameter sets, different security levels and parameter selections between implementations can be break compatibility. So here we use different kinds of security levels and parameter selections to implement implementations can break a compatibility. Means here we will check compatibilities. So example, Kyber 512 versus Kyber 1024 implementations cannot directly exchange keys. So means Means compatibility means whether it will work or not, we will check. Encoding formats. Variations in a key and signature encoding prevent proper verification across systems. Critical for a certificate chains spanning multiple CS and uh, jurisdictions. So algorithm agility. In algorithm agility, systems must support multiple algorithms and negotiable protocols during transition. So means compulsory system should uh, uh, support each and every algorithms or multiple algorithms. Negotiation failures common when implementation support different algorithms suits. So it is negotiation failure is common. So suppose if it is not support sometimes. Next, the geopolitical quantum security landscape. So, in that competition dynamics, so nations racing to achieve quantum advantage in a both offensive and defensive capabilities, strategic investment in a indigenous algorithms to reduce dependence on foreign standards, concerns about potential backdoors in a internationally standardized algorithms driving parallel development. Export controls limiting quantum security technology transfers to adversarial nations. So these are some national strategic interests in a quantum security. So United States, in European Union and China and Russia. So we already discussed these things in a previous slides. How much investment they are doing, in how much investment they are investing in quantum security. So international collaboration mechanisms. So despite competition, several frameworks facilitate essential quantum security collaboration. So how they are collaborating? So Open QKD, EU funded test based for interoperability testing of a quantum key distribution systems. Quantum Economic Development Consortium, public-private partnership advancing quantum technology supply chains. So, Global Forum on Cyber Expertise, platform for a knowledge sharing on a quantum safe transition tech strategies. APEC Teleworking Group, so coordinating Asia Pacific quantum security standards for telecommunications. I think we already discussed these four in our previous slides. Next, towards a global quantum secure infrastructure. So, the vision of global interoperability quantum secure communication infrastructure requires unprecedented international coordination. So, space-based networks, uh, terrestrial backbones, and certificate authorities. So, these are the some global quantum secure infrastructures, space-based networks, terrestrial backbones, and certificate authorities. So the next thing is ethical dimensions of a quantum security. So what are the ethical dimensions of a quantum security? So with a great cryptographic power comes a great responsibility. So quantum resistance cryptography isn't just a technical challenge. It presents profound ethical questions about security, power, and access in the digital age. Means how much security it will provide, on how much fast it will work. So all those comes under in this ethics only. As we implement these technologies, we must consider who benefits and who is excluded. So to whom it is benefits and who is excluded. How do we prevent misuse while enabling legitimate security? And what value should guide our deployment decisions? So these will comes with these we need to consider while implement the quantum technologies. The next thing is ethical responsibility in deployment. So how we are deploying, how we are using ethical responsibility in a deployment of quantum security, quantum computing. Security obligation, responsible access, global equity. So in security obligation, organizations have an ethical duty to protect sensitive data with the strongest available cryptography. Means organization should use strongest cryptographic techniques to provide security or to provide a protect to our sensitive data. So next, responsible access must balance legitimate security needs against potential for a surveillance or oppression. So here we need to balance everything. So next, global equity, ensuring quantum security doesn't become exclusive to wealthy nations or organizations. Risks of misuse and abuse. So what are the risks we will get if you misuse or if you abuse mass surveillance, uh, authoritarian control, and criminal exploitation. So quantum secure challenge could enable unprecedented surveillance if backdoors are mandated by governments. So danger of creating unhackable monitoring systems that are immune to whistleblower exposure. So next, authoritarian control, selective deployment could enable secure communication for regime officials while citizens remain vulnerable. Risk of creating cryptographic divide, reinforcing existing power imbalances. So in criminal exploitation, quantum resistant encryption could enable untraceable criminal communications and ransomware operation. Challenge of balancing legitimate security needs against law enforcement access. So next, digital inequality in a quantum security. So elite organizations with the leading edge quantum secure systems, first. Second, large enterprises with a partial quantum protection of critical assets. Mid-sized organizations with limited post-quantum implementation. Small business and organizations without resource for a transition, and individuals and communities with a vulnerable legacy systems. So this is a digital inequality in a quantum security. So this is indicated with step by step. Without deliberate intervention, quantum security will likely follow existing digital divides, potentially widening economic and social inequalities as the quantum attacks become feasible. So national security versus individual privacy. The security dilemma, quantum security creates renewed tension between government access and a personal privacy rights. Intelligence agencies seek access to encrypted communication to prevent threats. Intelligence agencies, what will they do? They will seek access to encrypted communication to prevent threats. Privacy advocates warn against undermining cryptographic protection for all. Commercial interests push for a strong encryption to protect business operations. Finding ethical balance requires transparent, democratic decision process. So this is the national security versus individual privacy, how it will be. So an ethical roadmap for a quantum security. So this is a roadmap for a ethical roadmap for a quantum security. So in that, the first one is ethical assessment. So inclusive design, the second one, transparent governance means we need to trust educational access. So in ethical assessment, conduct comprehensive stakeholder analysis and ethical impact assessment for a quantum security deployments. In an inclusive design, develop implementation approaches that address need of disadvantages communities and smaller organizations. So we need to develop the implementation approach that for what purpose? To address the need of disadvantaged communities and smaller organizations purpose. Transparent governance. We need to structure the governance with a trust. So establish open multi-stakeholder governance mechanism for a quantum security standards and policies. Educational access. Create free resources and training to democratize the quantum security knowledge beyond elite institutions. Key ethical principles for a quantum security. So these are the some key ethical principles for a quantum security. Responsible innovation. Transparency means trust. Our innovation should be responsible, and we need to provide a transparency, and we need to build a trust. So in that, the first one is responsible innovation. Anticipate and address potential harms throughout the development process. Incorporate ethical review into algorithm and protocol design. Protocol design phases. Next, in a transparency, open a process for a standards development with diverse stakeholder input. Clear communication about security guarantees and limitation. We need to provide the clear communication and security guarantees with the proper limitations. Trust building. So develop accountability mechanisms for a quantum security implementations, regular third-party verification of security claims and implementations. And the next one is key takeaways. International standards organizations are covering around NIST algorithm selections, but regional variations persist. Interoperability is critical for a global quantum security, but faces technical and geopolitical challenges. National security interests drive both competition and necessary collaboration in a quantum security, and ethical deployment requires addressing access inequalities, privacy concerns, and potential misuse. So, successful implementation demands technical excellence with ethical governance. So, these all are the concepts which are related to policies and governance and ethical concepts, how we are implementing these three in our quantum security. So if you want to develop a quantum security in a better way, compulsory first we need to find out the problem or issue. Based on that, we need to provide some principles or guidelines. So that is nothing but a policies. After providing the principle and guidelines, so we need to form as a team, and we need to take the decisions based on each and every policies. So that is nothing but what a governance. So after that, we need to provide a some ethical concerns, like we need to provide a trust. So as well as we need to provide some securities, and so means we need to tell which one is good and which one is not. So everything we need to do in an ethical things only. So this is the thing, and this is the concepts which is related to policies, governance, and ethical things we are using in our quantum securities. So this is the today's session, and thank you. So so the session is over related to policies and governance and ethics which are used in quantum security.
Thank you very much, sir. Is I'm audible, sir?
Sir, yes, sir, you are audible.
Hello.
Yes, sir, you are audible.
Thank you very much, sir. Your session is very informative. Definitely, it is useful for to us and our participants. Whatever the insights you have provided, definitely useful to us in our career as well as in our future endeavors. Thank you very much, sir. Hello. So all the participants, feedback link for the second session will be posted in chat box. Please submit that. After submitting, please also submit the quiz. After giving the feedback and submitting the quiz, you can leave the session. All the participants are requested to submit the feedback form as well as quiz, which is available in chat box. Is I audible, sir?
Yes, sir.
Okay. Yes, all the participants are requested to submit the feedback form as well as quiz, which was posted in chat box as well as in our WhatsApp group. After submitting, you can leave the session. All the participants are requested to submit the feedback form as well as quiz, which was available in chat box as well as in our WhatsApp group. Thank you. After submitting, you can leave the session.